Hey, it's Chris from Chris Crafts Code. I am a CS student who's just finished his first semester, so it's been like 4 months since I started programming, and this channel is pretty much just going to be practice and documentation of the code and project I'm working on until I get a job, probably. So we're going to make a deck of cards in C# in a console app. Alright, so let's get started here. We're using Visual Studio 2022, which the enterprise version, which I won't be able to use out of school, but might as well use it now. That's what we have to use for school anyway, so I'll get used to it. I have, however, deactivated the suggestions feature and the autocomplete thing. So I'm not too sure what the extent of the project will be, but to start off with, we're just going to make a deck of cards to be able to manipulate and kind of evaluate the cards, see like are these two cards the same, is one stronger than the other, and then once we have that working, we could use that to make games or some other programs or whatever. I was going to make the deck cards into a 2D array. I might get some terms messed up a little bit because where we are situated, the education is in French, so there's some things that might mess up the translation of. But I think we're going to do it just in a normal array. And I thought about it, and I don't think we're going to regret this, but we're going to make it a string array. So a single array of 52 cards, the cards are going to be represented by strings. So for example, in Ace of Spades is literally going to be called Ace of Spades. Alright, so I'm pretty confident that we could write something clever to fill up the actual deck of cards in like a for loop, but we're not going to try to go too clever right now. I think it'd be a pain to maintain if we want to change things later. We might have a game where we only have 50 cards and remove the two jokers, and then our thing wouldn't work. So this is how we're going to do it for now. Just straight up, here's our array, here's the position, or the index, and here's the card. So now to do this 51 more times. Alright, so here's all our cards put into the deck of cards, and we separate them by their suits. I guess we could start off by just displaying the whole deck of cards, just to make sure everything's working right. So here we go, let's do a for loop for int I equals nothing, or 0, not nothing, as long as I is smaller than 52, and then increment that, and then we'll just write s cards, which is our deck of cards, at the index of I. Alright, and if we just eyeball this real quick, Ace of Spades, 2, 3, na 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 na, until the King of Spades, Ace of Hearts, na 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 na, until the King, everything seems to be in place. We'll go ahead and comment this, or just delete it, we don't need it really. Alright, so now that we do have our deck of cards, and the cards are in there, we could try to like evaluate them in some sense, because right now they're just strings, so they don't have any value really to play any games. I looked it up beforehand, and from what I can gather, the Jack, Queen, and King are all evaluated at 10, and I thought this was just in BlackJack, but I think they are just considered to be of value 10. But when you play games like poker, the King still will beat Queen and the Jack. I think what we're going to do is if we make games, we're going to make the games inside of functions, and then maybe those functions have to call other functions, so that the values of each cards will be dependent on the game, versus setting a value inherently to the card and then having to reset it, reassign it later on for another game. Alright, so I think what we could do to start off with and have something to kind of test the waters is not necessarily a game, but just taking our cards, and let's say we draw 2 randomly and then evaluate which ones are bigger or stronger than the other. We're gonna evaluate based on the actual string, the name of the card, and find a way to evaluate it off of that anyways, because I don't want to like work off the index and be like, well, if you get the card that's at this index and is stronger than this one, but then we can't shuffle the cards. Alright, so let's go down to here and write a function. We'll call it strongest of 2 cards. I know. So we're going to have to take our deck of cards in as a parameter. We're going to need something that's random to actually draw the cards randomly. Go make a random. We'll call it draw. Alright, so now we're going to need 2 strings for each of our cards. So we'll go card 1, card 2. We're going to want an integer, call it the draw. So we'll start with this, and before actually worrying about evaluating them and seeing which one's strongest, we'll just take this and work it so that we can actually draw the cards and display them and make sure that's working. So for our first card, let's go with draw is equal to, we called it draw, not next. We need to add static before it, don't we? Next, we're going to go with from the first index to 52. So now with this, once this draws a random int between 0 and 52, not inclusive, so 0 or 51, that'll be our index for the card that we're drawing. So yeah, S card 1 is equal to, and then deck of cards at the index of our draw. Now we could just duplicate this, change this for card 2. That'll work, it'll run, but we'll have the issue where there is still the chance that we draw the same card twice, which isn't like in real life possible. I just realized I didn't add jokers in here. Let's fix that. Nope, I changed my mind. No jokers. We have this here, which we could draw the first card and then draw our second card and assign that string to the variable of S card 1 and card 2. But there is the possibility that we draw the same card twice, which we don't want to actually happen because it doesn't make sense. So I think the easiest thing to do here is we draw the first card, and then on the second card, or for the second card rather, we just insert that into a do while loop. So it'll do it once, and then it'll evaluate, and our condition is going to be do it as long as S card 1 is equivalent to S card 2. So I don't think it'll loop very much, but on the off chance that we do draw the same string for card 1 and card 2, it'll loop again, redraw, and take another card. And then, just to see if that's working, let's go ahead and display the cards. Cool, so we'll come work on this a bit later. Let's go back up to our main, and then at the bottom here, we could probably actually stick this into a function later just to clear up our main to make it a bit more readable. So here we want strongest of 2 cards with a capital O, and we need our S cards array to be sent in as a parameter. And there we go. Let's just try it. Alright, your first card is a 10 of clubs and your second card is a 5 of spades. Alright, so we've done that real quick. Now we have filled the deck. That takes in the cards here, and then we have the strongest of the 2. So it still works the same. It's just the main is a bit more clear, and here it is. It's just the same code copied and pasted into a function that we're going to call. So now in the main, we start, call this, send that in as a parameter, fill up each index with a card, ace of spades, 2 of spades, come back to the main, call upon strongest of 2 cards, send in that same array now with the cards inside of it, and then we draw 2 cards. Now we're at the point where we have to think about how are we going to evaluate these cards and see which one's the strongest. Alright, boom, Excel jump scare. So I figured this might be a bit more visual to explain what I think I'm going to do to evaluate the cards. And by the way, while I'm doing this, as I said earlier in the video, I'm just getting started, so there's probably a bunch of things I'm doing weird, odd, not optimal, so I'm open to like ideas and suggestions in the comments. So anyone who is new to programming, like, don't take what I do necessarily as the best way of doing it. I'm still learning. So here we have an example of a card. So 2 of spades. So we have the 2. These are spaces. Here, let's actually make this a bit clearer. There we are. So 2 of spades right here. And up top we have the index of each jar. Something we can do in C# is kind of mess around with strings and evaluate, not evaluate, but like find positions of certain chars or whatever. So what I'm planning on doing is for every card, we start off with what the card is. So ace, 1, 2, 3, 4, 5, all the way up to king, followed by a space and then of the suit. So I'm thinking what we do is we take, for example, we use the index of space, and then with that we'll find the index of the first space in every string. And it doesn't matter if we have 2 or if we have something like king that has 4 characters. We'll find the first index, and then we can have a substring, which is going to be from our main string, starting from the index of 0 to the index of spades. All right, so let's get to work on actually making that come to life. So we're going to add a little console write to make this cute. Press any key to continue. We're going to have our read key. So as mentioned before, we're going to want a substring. Let's separate them by, like, put them together. So string, we're going to call it card value and second card value. We're also going to need an integer for our index. And we're going to need some kind of number to assign the strength of our cards. So let's go with bytes. All right, so we've drawn the cards, and now we need to get the value of the cards. You know what? Maybe we are complicating this. Maybe we don't need to have a new string for a substring. Let's leave these here, and we'll clean this up later if we don't need them. But I think what we could do is scard. So what this should do is it'll read scard1, which is, well, it's random, but let's say it's ace of spades. And it'll find the first index, or the first instance of space, which should be after the value. So if it's 2, it'll be after 2. If it's after ace, it'll be 0 is A, C is 1, E is 2, space is 4. Index should be 4. So now, if we do scard1 is equal to, well, yeah, equal, sure. We reassign it itself, but we substring that string from 0 to index of space. Now, if I'm not miscalculating this, what this will do is, once again, let's say it's ace of spades, it'll give us ace, but it'll also give us that space after, which we don't want. So what I said before is we could take index f minus 1. So now this should give us the first card, but just its like value without the of the suit. So once again, we can also just verify this right now. Let's just console write line, and then we'll do scard1 and see what that gives us. All right, see, so I did do a miscalculation. Our ace is missing its E, so we don't need the 1. All right, see, and this is because I misremembered how to use substring. I read it as your start index and your end index, but it's not that. It's the start index and the length of the string that you want. And if we run this a few more times, it should work. All right, our first card is the 4 of hearts, returns 4. First card is 4 spades, returns 4, jack of hearts, jack. All right, so this works. Cool. So with this, we can just copy this, and then we change card 1 for card 2. So now with S card and S1, instead of having our full card, which is whatever of hearts or spades, we have the value, and that means we can get rid of this. With this, now we have the value, but it's still a string, so it doesn't really have like a mathematical value that we can use. So I think probably the easiest for now would be a switch statement on S card 1 to start with, and then we'll have another one for card 2. So we go for case, and then it is still in strings, so it's gonna be ace. For our little game thing, we're gonna consider ace as being 1, and it's gonna be defeated by a king. B card 1 equals 1. Now we do this 14 more times. So if we get 2, we send the value of 2 to the card. We get 3, we send 3. And what we're going to do to evaluate if the king is stronger than the queen and whatnot is we're just going to simply build up from 10. So 10 is 10, jack is 11, queen is 12, and king is 13. All right, so here are 2 switch cases to assign the values or the power of each card. Same code. We just changed S card 1 for S card 2. And then here we're going to find the strongest card. So I think the easiest here is just go with ifs and else's. So if B card, not B barred, B card 1 is equivalent to B card 2, I'll be right, both cards are of the same value. If B card 1 is bigger or greater than B card 2. Oh, so here's a thing. We could write the first card is bigger than the second, but that's not as interesting as taking, it's not as interesting as saying the king of spades beats the 10 of hearts. So let's go back up to our code and see what we can do about that. This is where the problem comes from. So maybe let's just, we'll go here and we'll add we'll re-add some new strings. Here, full card 1, full card name, there we go. Full card name 2, and then we'll just quickly fix this up. So here we're going to change this by full card name 1, and then here we're going to switch these out as well. Cool. Now instead of having S card 1 and S card 2, we have S full card name 1 and 2. For the index, we're going to have to change it for full card name 1 as well. But then this S card is going to stay, so that way we don't have to change up everything in the switch statement. Our evaluations are still good, but what we can do here is full card name 1 plus is stronger than space concatenate S full card name 2. Let's test it out. All right, the first card is the King of Hearts. The second card is King of Diamonds. Both cards are of the same value. Seems to work. Let's try it again. First card is the Jack of Spades. Second card is the Four of Spades. The Jack of Spades is stronger than the Four of Spades. One last time. First card is the Two of Hearts, and the second card is the Five of Hearts. All right, I think all 3 draws we've gotten 2 of the same suits. So let's just. All right, cool. Must have just been a coincidence. This time we have 2 different suits, and the evaluation is correct. All right, new day, new year, same old me. Let's get to work on our first game with this code here. So I think what we could do is start off with a game of BlackJack, because it's a game that'll be quite easy to simplify. If we just have us versus the dealer, and we can start off with like limited rules, so no like betting or anything. We just have 1 game at a time. We don't have to from the get-go make the dealer draw extra cards. You know, it could just be limited at 2, and then once that is working, then we can add some more functionalities, like having the dealer be somewhat intelligent and try to, you know, cap out near 21 and beat us out. All right, so I just recorded a whole 5 minutes of nothing because the microphone was muted. So what we're doing is, I was debating on how we deal with the cards, because we could, for the game, use the same logic to draw the cards and have it in a do while, and it would work, especially at the speed of the processor. And you know, we only have 52 cards, so even if it does loop a few times because we draw the same card twice, I don't think we're going to feel it that much. But you know, keep in mind we are high level at the moment, and the other idea that I had was going with a list, and I don't know which one actually is more efficient processor wise. But what we could do with a list is, instead of like having a do while loop, is let's say we put all our cards into a list, then we draw our card, and let's say that card was at index of, we'll go at 13. So where is that? Let's go find our fill the deck. Here it is, fill the deck. So index of 13 is the Ace of Hearts. So we draw the Ace of Hearts, and let's say that is first card for the player. Then what we can do is we take the list that contains all the cards, and then we remove the 13th position. So we remove at index 13, and what that'll do is it'll remove the Ace of Cards from the list, and it'll also remove its position and then shrink the list. So 13 will just be gone from the list, and then what was at 14 becomes 13, and so forth. So that way we don't have to like loop it. All right, I think we're ready. We'll add things if needed. So we have our list here, which is deck of cards, and then we have the same logic as up top for the strongest of 2 cards, but we have, the names are just a bit better. So we have the first card's power and the second card's power. And do we need power? No, we don't. We'll go with the total for the first player, and then we'll do the same thing for the dealer. So what we can do is we'll take our same switch case as earlier, but instead of like having the power, we just add like, let's say we have 2 and 3. Okay, so we take the first card, the 2, go with our switch case, it's 2. Then we add 2 to the total, and then we have 3, and, you know, and so forth. All right, so the first thing that we're going to need to do is actually fill up our list with the cards in the deck of cards. So we can use a method that's just called add. Yep, that works. So that what that does is it takes what's at the index of 0 of cards and adds it to the list. Cool. So what we're going to do here is, instead of doing it 52 times manually, we're going to put this in a loop. Good. So this sends our cards from the array into the list. Now we can start by, I guess, just drawing our 4 cards. So the 2 for the player, being us, and the 2 for the dealer. So I'm pretty sure it would be like, 1 card player, 1 card dealer, 1 card player, 1 card dealer. We're going to go from 0 to, and now instead of doing 52, we're going to use the size of the list, which is count. Okay, so we're back. Had to babysit after that last clip. I haven't done too much since. I made a little bit of a menu since I figured it wasn't critical for the actual video, but it makes it a bit more fun to interact with. So we have 1 being our strongest of 2 cards function that we made, and 2 is our BlackJack function. And then if we screw around with it, then, I've been thinking about our BlackJack game and we're not very far in, but I'm not sure about this anymore. I'm worried that if we want to expand the game later, like let's say we add more players, let's say up to 3 plus the dealer, we'd have to have like a variable for every card of every player. And then if you factor in that sometimes your hand can go up to 5, 6, 7 cards, then you'd have to have like first card player 1, second card player 1, all up to 6, and that for every player plus the dealer. And it's not like that'd be complicated, but I don't know if that's the best route. So maybe the best would be to get rid of these, and then we'd have like first player deck or hand, and have that be a list, kind of like what we're doing here, so that, it's adaptable and there's no set value at the start of each round. So if we have 2, then we just have 2 cards used. If we need to hit and take 2, 3 more cards, then it'll expand with the game. And then at the end of each round, we could probably just like throw it into a loop to remove every item. It's like probably for each loop. I think that would reset it and then we'd be fine. All right, so we've gone ahead and swapped that out. So now we have these here that are effectively useless. We can delete them. So we have the first player's hand, which is a list of strings, same deal as the actual deck of cards. And then we have that for the dealer's hand as well. And this will be very simple if you want to do this, and then we do second player's hand, and then third player's hand, but we'll do third player hand. And then if we go down to our logic a little bit lower, we have same deal. The syntax changes because we're not using the same thing, but we draw a number between 0 and the count of the deck of cards, so it starts at 52, and then we take that card and add it to the first player's hand. Then we remove it from the deck of cards. Do the same thing for the dealer, and then you'll notice that for the cards, for the second cards for each player, this code here is the same thing as here. There's not even a difference in indexing or anything. It's the same. So that opens up some interesting possibilities with like for loops. Or so what I think we'll do to start like making this evolve a bit is start by building up the game to just play a single round. From there, we can start adding more features like the rounds and doing the hits and getting more cards and whatnot. But we'll start with just like single rounds, and you just have the cards that you're dealt. So we might add this into a function later, but since it's specific for the game, maybe not. So we'll just label this section right now as the deal. Well, just for myself, we'll call it the initial deal. So now we have this. We can just loop it twice. Very simply. All right, so now the first thing to do with this is we'd have to evaluate like what is the total that each player has in their hands. So we did do that earlier in strongest of 2 cards down here with our switch case. But what we're going to do is we're going to take this section here and turn it into a function so that we don't have to have like this copied 50 times in the BlackJack game. We could do it card by card, but if we look a bit into the future, we're gonna have to deal with aces that can be either 11 or 1, depending on the context. We need to know the other cards in the hand to determine what the context is. The context being, the ace will usually be worth 11, unless that makes the player bust and go over 21, in which case it'll be worth 1. So we're probably gonna send in just a whole list. Guess we'll call it a hand summation, but we're for BlackJack specifically. All right, so we're gonna call it. We're gonna have to send in our hand that's being evaluated. So let's go ahead and grab this whole thing here. I'm just gonna copy it over, and we're gonna have to tweak it somewhat, so I'm just gonna copy it, think, and then come back. Alright, so I think we got a little bit of a something. So what we've done is we have a byte for our card value, a byte for our hand value. We brought back the index, and then we have an extra string, which is the card value. So this is the result of using the substring to find the value at the beginning of the string that we had before. So we have, oh, this isn't gonna work. We have this whole thing in a for each loop. So essentially for each string, that is, we're gonna call card in the hand that we're sending in as a parameter, we are going to find the index of the space, and then from that create a substring, which we're going to call the S card value. Same as before, to find like the first character, or if it's an ace, like the 3 characters, to find the value of the string, of the card. And then with that substring, we're going to add, well, we're going to take that and put it into our switch case, same as before, to find the value. Take note of this. We'll come back to it later. So once we've done this and found the value of the card, which actually now that I'm looking at it, for BlackJack, this has to be all 10. We find the value of the hand so far by adding up its current value, so it starts off as 0, plus the card's value that we found here. And we have to cast it into bytes because I guess in C# there are no arithmetic operators for bytes. So it casts it into ints, so we have to recast it back into bytes. Now I'm confident this will work. It doesn't like have a flexible ace, but it should, you know, function. And then what we could probably do is return, I guess, this. So if we go back up to this, we're going to return a byte. So we'll keep this as such for now. Let's go back into our BlackJack game. Hand summation, BlackJack. We're going to send in the first player's hand. Oop. So that should return this. Actually, let's uncomment this. And just to make sure it makes sense, we'll send it before the function call. And then we'll do the same thing here, but for the dealer. So now we draw the cards, we display them just so we can keep track, send them in to calculate the total. And then for here, let's go ahead and we'll print out those totals. Here's a menu, 2 for BlackJack. All right, so we have the 3 of hearts plus the queen of spades. And then we have the king of hearts and the ace of spades. And now very evidently, something is not working. Alright, so I'm just going to inspect the code, and if I can't find it right away, then we'll go into debug mode. Okay, I think I see the problem. What happened is when I put the return here, I took this out of the loop, so it doesn't actually add up every time. So let's grab just this, stick this back into the loop, and that should fix all of our problems. Alright, so we got it working. I blame all y'all. I think talking and thinking and coding is throwing me off. It's hard. So that works. We have 4 and an ace, which is 5, king and 2, which is 12. Do it again. 5 and 4, 9, 7 and 2, 9. If you didn't spot the issue, when I took this and copied it here to put it into the loop, I didn't remove the actual operation here. So as it was returning, it was like re-adding the second card, I believe, that was like evaluated. So like if it was a king that was the second card, then it had like a +10 all the time. And while I was fixing this, I got an idea for how we're going to deal with the contains in ace branch. What we're going to do is we're going to take this kind of idea here, and before actually going into this for each loop, we're going to have 2 variants. We're dealing with the list, we got to make sure we call this right. So if hand, if we contain ace of spades, or if it contains ace of clubs, or ace of diamonds, ace of hearts, then we will not do the evaluation. Well, we won't do like this section for now. All right, so now there are a few ways we could go about this, but I think what we're going to do is once we land into this branch here, we're going to reuse our index trick to find where which position of the list the ace is located. And to do that, we're going to retake these conditions, but do them one by one. And we're going to deviate from our original plan because there is a possibility of having multiple aces in your hand. So let's have... This might not work at all. I'm kind of doing it as we're doing it. So here, byte number of aces. So if it contains the ace of spades, then we're going to increment this, and that's going to be the same for each and every condition. So actually for now we don't need the brackets. Nope, we do need the brackets. So we're going to count the number of aces that we have, and as we're doing that, once we count an ace, we're going to remove it from our hand, because it's kind of pointless to go and like substring it and evaluate it if we know it's an ace. That's all we need to know. We increment this, and then we're going to take hand and then remove at index. So the idea is that if it contains an ace of spades, we increment our counter for how many aces we have. We find where that ace is in the deck, not in the deck, in the hand, sorry. So if it's card 1, then it'll find 0. If it's card 2, it'll find 1. And then we remove it from the hand. And we're going to do this for each and every ace. Okay, so now that we have found how many aces we have in our hand and remove those from our hand for the time being, now we can go ahead and remove this, because technically if you come down this branch, we don't have an ace. So we can remove this and take this same logic here and stick it into here. Cool, so now what we have is we have our number of aces, we have this to evaluate the value of the remaining cards. So like at first there's only be one remaining card, but if like eventually when we add the hit function and then we have like 4 or 5 cards potentially, then it'll summate like the rest of those, bar the aces. So now to add in the aces, what we're going to do is, let's just for now do it as if we only have one ace. This is basically saying we have our hand value so far. So let's go with the presupposition that we just have 2 cards. Let's say we have an ace and a 5. Okay, it's a bad example for this. Let's say we have 3 cards, because otherwise it doesn't work. So this is not really going to activate anytime soon. Let's say we have 3 cards. So you have a 10, an 8, so we're at 18, and you have 1 ace. So if 18 plus 11 is greater than 21, which it will be, then we're going to evaluate the ace as being 1, which is why here we do the value, which is 18 plus 1, so it gives us 19. Now, in our situation right now, where we're only going to have 2 cards anyways, even if, let's say, we do have 10, we're going to have 10 plus 11 equals 21. So we're not going to do this. We're going to do this, which is our value so far, plus 11. So this is the ace evaluated at 11. So now I think, pretty sure that if we put this in a for loop, we do I is smaller than the counter that we had going on, so the amount of aces. What this should do is if we have 2 aces in our hands, it should do all this twice. Now looking at it real quick, I think we are good to try it out. All right, so we have 3 clubs, 5 of hearts, that's 8. Ace plus 8 gives us 19. That's a good sign. 15, 21, seems to be working. Okay, now that we have that, I guess we could go ahead and like start configuring our winning conditions and seeing like if we beat out the dealer, and then like eventually when we add in stuff, we'll add it between like these steps. All right, so I'm getting a bit hung up on these conditions because I'm kind of like thinking maybe a bit too far ahead, where like in blackjack, while actually playing the game, the pacing will make it so that when you announce the results kind of change. Like if the player busts, we're gonna see that before the dealer busts, right, all the time. So like the player can lose before the dealer actually like reveals his hand and we actually get to evaluating that. So for now we'll keep it very simplistic, and then as we're developing it, we will flesh out like the pacing and when everything shows up in the code, because if we try to like do it now, I think I'll just get lost in it a bit because it is still kind of intricate. All right, so with this we should be good to find a winner. Let's run it. Let's try it out. All right, so we have 7 plus a jack, that's 17. 6, 5 is 11. Player 1 wins. Oh, very good. Player 1 pushes. We got, oh, cool. We got a draw. The dealer wins finally. It's 1:17 a.m. Let's try to see if we can get the player's turn to function. So by player's turn, I mean once he gets his 2 cards, he can look at them and decide, am I going to hit? Which means get another card. Are we standing? And yeah, let's try to work this out. So this is going to work effectively kind of like a menu. So let's go back up to our variables and we're going to use chars. We'll specify for BlackJack. I don't think hit, just in case hit is used in another game, it would make more games further down the line, so it'll still work. So we want hit and we want stand. Actually, no, let's do it in the loop. So we'll get our summation done. So we're going to put it to upper so it always works. So as long as we don't hit S, we should stay in the loop, which right now it's not doing anything. It's just going to write this infinitely. And then once we hit S, we should exit the loop. So if we hit H, which is what hit BlackJack is, which we can see here, we're going to redo the draw for the player. So if we hit, okay, so if we're here, we hit H, it evaluates. H is hit BlackJack, it hits, it draws, it adds that, and it removes that from the deck of cards. We exit out. We didn't hit stand, so we go back to the top. Blah 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 blah. We summate it, and then we can loop this forever. Now we're gonna want to add another condition so that once we hit 21, it automatically stops. Or if we bust, we automatically stop. We're going to automatically assign this to player choice equals stand. So now we have the initial deal, and then we see our cards, and then it's the player's turn. So we summate it. We have this many points, let's say, and then if it's greater, if it's 21, then automatically we stand. If not, if we busted, then we indicate that we busted, and then we change the choice for that and exit the loop eventually. If neither of these are true, then we get to have our choice. Do we want to stand or do we want to hit? Eventually we exit the loop, and then we can get rid of this line here because it'll already have been done in our loop here. And I think the rest we're gonna have to clean it up, but we can leave it as is for now and just see if it's working. Okay, cool. So we got an ace and a king, a queen, and a 5. It seems to be working. I'm going to do some off-screen coding real quick just to make it look a bit nicer so it'll be easier to follow. Alright, so that should be a bit easier to read. Now let's go try it again. So we have player 1's hand, which is a 10 and the ace of clubs. Well, 10 of hearts, ace of clubs. Dealer's hand, which is a 3 and a 10. So player's one hand, currently he has 21. So automatically he stands. Cool, that works. 21, dealer has 13. Player 1 wins. Right, let's try another round. BlackJack. Okay, we're gonna stand again. Cool. This time we don't stand. The dealer should have 18 when we're done. Let's see. So we have 4 and queen. We have 14. That makes sense. Let's try to hit. So H busted, but we win. Okay, so our conditions aren't quite working. So 2 things we're gonna have to fix. Here, what we're gonna want to do is, for one, make it so it's clear to read. That's just like some formatting. We're probably going to want to actually say what we've drawn. I just realized that we didn't add it, so we're just taking it on its word. And I'm going to fix up this here because we can't win and bust at the same time. Alright, so I haven't tested it, but I might make a fool of myself, but I think I fixed it. If we go back up, let's start with up here. Okay, so we fixed the formatting with some new lines and stuff. What we've done is we've added a string which is called sDrawNCard. So when we draw a card in our play, well, during our play, when we hit, we assign that same drawn card to this string here, and then we write that we drew the card. So that way we can just follow a bit easier and make sure it lines up. And then when we go down to over here, the conditions, I've left these in comments for now just in case, but what I've done is This here was the problem, because even though we busted, since we did have more than dealer, then it says that we won. All right, so now we're gonna bust. So we have a queen of diamonds, we have 28, we busted 28, we have 28, we busted, we lost. It works. Right, so me in real time, I'm gonna call it for tonight. Next time we work on this, which is gonna be in a few seconds for y'all, but next time we work on this, I'm just gonna have cleaned up the formatting and the way it displays, just so it'll be a bit easier to follow on your end as well. Okay, so we're back, and let's first take a look at the way the displays now. So we've cleaned it up a little bit. If you head into BlackJack, so this is what it normally looks like. We have 8 of clubs, 7 of spades, we have a total of 15. The dealer has a jack of clubs, and we can't see his second card yet, which makes more sense if we're comparing it to real life blackjack. We have hit, we have stand with our buttons, so it's a bit more clear what we should do. So if we have 15, let's go and hit. We draw the queen of diamonds, we're gonna bust. Alright, so here we are. 8, 7 queen, total 25, we've busted. He has a jack, and now he has a king. We see his total, which is 20. So we busted. Now we could make this better, but for now, like, the main focus is really on the logic and making sure everything works. So I'm not too fussed about it, as long as we can actually read it and it's not too hard to follow. Now I think for the sake of the video not going over an hour, we're gonna just now focus on the dealer's AI. So just decide on when he hits and when he stands, and then with that we will have a functional blackjack game. And then if I feel like it, or if this takes off and you guys want it, then maybe we can make a part 2 where we go and make this into something that's like multiplayer. We can have multiple rounds, maybe like a token system where we can bet and try to empty out the dealer or something like that. Now for our dealer's AI. So from what I've read and understand, in blackjack, the dealer actually has rules to determine when he stands and when he hits. It's not like just his instinct and him playing. So basically, if the dealer, and this is supposed to give the edge to the house, the casino, if the dealer is under or equal to 17 of value on his deck, then he has to forcibly hit to try to beat out the players. I think we're pretty much going to just want this logic all over again, but we have our condition here determining what the dealer does. So I'm going to just concoct that to try to keep this under 20 minutes, yeah, under an hour, and then I'll come back to you guys if it's done or if I have a significant change to bring to the code. All right, so that actually wasn't that bad. I will, before showing it off, let's go look at the code real quick. So what we've essentially done is copied the player's turn. We now reveal the second card for the dealer, and then everything that was like first player hand, we switch for dealer hand. And so we had the same initial conditions. If the dealer has 21, he's going to stand. If he has over a 21, then he busts, and then we go down that branch. This is where the actual dealer AI comes into play. If the dealer's total is lesser or equal than the minimum, which we established as 17, he hits. Or else, and this one is more specific, I think this is really depending on which casino you're at, but I read that some of them, they have like a soft 17. So if you have 17, but if you have an ace in your hand to make up that 17, that can become a 1, thus having more flexibility, then the dealer has to hit. Otherwise, we stand. So as soon as we're not within these two, we stand. And then we just go through this switch case to like do the same processes as before. And it works. I've retweaked the conditions and they're kind of disgusting. Usually I'd like fix this up, but for today's purposes, it doesn't really matter. Let's go and try it out. Now we have a jack of clubs, a 7 of harps of hearts, giving us a total of 17. The dealer has an ace of diamonds. We don't know what the second card is. We're gonna think like a dealer, and we're gonna hit. We're gonna bust. So we busted. The dealer has 21, so he's gonna stand. We have 10. We're gonna stand. No, we're gonna hit. Queen. So now we have 20. Now we're gonna stand. The dealer has 16, so he draws a 10 of clubs. The dealer busts, and we win. All right. So here I don't remember if we've seen it yet, but now the dealer made the 20, so he stands. Everything seems to be working. All right, so with that done, thank y'all for watching, especially if you made it like this far. Pretty cool. So we're gonna drop this as is, and let me know what you guys think. I think it was fun, and for sure, like, this might be really simplistic to some, but we're gonna do some cool things in the future for sure. If there's any like ideas you guys have, if you want to see a part 2 or any like corrections or like anything, let me know in the comments. I'll be down there for sure to chat with y'all, if any of y'all exist. And that's about it. I'll see you in the next one. See ya.